Okay, let's take a look at solving systems of linear equations. There's a few different methods in solving systems of linear equations. One of them is graphing, which we'll talk about more today. The other situation is that you can use the method called substitution and also elimination. So there's different ways where we can find where these two lines intersect. And that's what we're doing with systems of equations. We have two lines, and the point where they intersect and meet is the ordered pair, and that is our solution. And then we just have different methods of getting there. The graphing one is pretty basic. Nothing really new going on here. If you already been through the rest of the course and you're now at systems of linear equations, that means you already learned how to graph a regular equation. And so now all you're doing is graphing another one. You graph one line, graph the next. Where the two lines meet is your intersection. So looking here, this line is ready to go because it's in slope-intercept form. So we can start with this line and say, let's start graphing this. The y-intercept is 5, so it's 1, 2, 3, 4, 5. And then our slope is 1. And so that means we're going down 1 over 1. Over 1. Down over 1. Okay, so we have our line here. The second one is not quite ready to go yet. It's a small little move that we have to make, which is get y by itself, so we can move the 2x over to make it negative 2x. So this would turn into y equals negative 2x minus 1, and so now we can graph this one. Starting with the y-intercept of negative 1. And then our slope is negative 2. And so we want to go up 2 over 1. Up 2 over 1. And 2 over 1. And now we're right at this line. This intersection right here. Okay. So there's our two lines. Sorry, this is a pretty wiggly, scary looking line, but it's a line anyway. It's okay. So our intersection is right here, which is what? Negative 2, 1, 2, 3, 3. That is your solution to the system of equations by graphing. You just graph one line, graph the next line. The point where they meet is the solution. And this is how you would write your answer as an ordered pair. While we're here, let's talk about the other special situations. What if you have an equation where you have, for instance, y equals negative 2x minus 1, but then you have another equation that it's y equals negative 2x plus 3, for example. Okay, well now, this is a special situation. So these are parallel lines, and they will not intersect. So when this happens, we say there is no solution. The next special situation is, what if you have, what do I have? Y equals negative 2x minus 1, and then you have y equals negative 2x minus 1 again. Or maybe it's in standard form. So then you have the same exact line. So when this happens, then our special situation says that we have infinite solutions. Okay? So those are two special situations. Again, you can either have two lines that are parallel, same slope, okay, and then we say it's no solution because they're running like this, or you have the same exact line twice, which means it's a solution all day long, up and down the line. Every single point's a solution, and so that would be infinite solutions. Okay. Again, there's three main ways to solve system of equations. One is graphing, which we did right here. The other one is substitution, which sounds like you substitute an expression into another part of the equation, of another equation. And then elimination, well, that sounds like what it is as well, which is when you eliminate one of the variables first. Okay, that's it.